let's talk a little bit about asynchronous operations. Now, this is a really big topic, and there's an awful lot that goes into it. Now, just like before, we're going to stick with the tack that we've taken up until now, which is we're not going to get really deep into the concept here. There's an awful lot that's written on asynchronous programming, and specifically async await, which is what we're going to be taking a look at. If you've done, say, C# or JavaScript or TypeScript, I love TypeScript, you've very likely experienced async await. They're really common in those environments. Well, JavaScript becoming more so than it was in the past. And so what we want to do here is take a look at how this is done in Python. So I'm going to start off a little bit by talking a bit about what asynchronous programming is all about. We'll take a look at a synchronous example, and then we'll get in and see how we could do that asynchronously and the performance improvement that we're going to wind up getting here. So the long and short of it is the fact that the waiting is the hardest part, that certain operations just take a little bit of time. Maybe I'm making a web call, I've got network I/O, I'm doing some fancy processing, whatever it is. And we don't want to stop everything just because one operation is taking its own sweet time to do whatever it is that it's doing. Now, this basic concept of being able to execute some bit of code or being able to mark our process as sleepable while something else happens, maybe outside of our app or otherwise, all of that falls under this very large umbrella of concurrency and parallelism. And again, this is a really broad topic. We're not going to get real deep into it at all. This is basically the main slide that we have on this. And what I want to highlight is the fact that really any programming language, any framework is going to have some level of options that you'll be able to take advantage of when it comes to concurrency and parallelism. And Python is no exception. That we have a lot of different ways that we could actually spin up threads, that we can go ahead and do locking to make sure that values aren't changing unexpectedly, or that if we go in and change a value, that we're not going to mess somebody else up, something else up, etc. What we're going to do with our demo is we're going to focus in on probably the most common scenario, which is a web request, because just HTTP or HTTPS, it's a heavy protocol. And so just having to wait for that request to go up, to come back, just the buildup and the teardown of that connection in and of itself takes a little while. So it'd be nice if we could go ahead and mark our application as the fact that it's going to be running this, or maybe be able to just do something else while that long-running operation is taking place. In Python, starting with Python 3.4, we got this async I/O module. And what this is going to do is it's going to graft or bring asynchronous development into Python. And async I/O is going to give us all the usual suspects when it comes to doing some form of asynchronous programming. It's going to give us asynchronous streams. It's going to give us the ability to do synchronization or locking, unlocking. It's going to help us out an awful lot with exception management. That one of the things that can get really tricky really quickly is if I'm creating another thread and that thread throws an exception, how am I, if I'm sitting over here, know what's happened over there? So making sure that our exceptions bubble out appropriately, all of that is really important, and the async I/O module is going to take care of that for us. The big thing that it's going to do is it's going to give to us async await. Let's talk a little bit about async await. So here's a big block of code here, and what I want to focus in on is a couple of really important keywords here. And the first is going to be await. What await is going to do is it's going to logically pause our code. That the next line of code here, this little line of code, let's just go ahead and number that as, let's just say the number 3 here. There we go. So our third line of code there, that's not going to execute until the operation up above completes. So if we stop and we look at this, this looks very synchronous because that's normally the way that our code works. That normally what happens, we have line of code gives us a value, line of code gives us a value, line of code gives us a value. We're all used to that. That's normally the way that our code behaves. What's happening here, though, is different. It looks a little subtle, but it's different in a very big way. That while, yes, by my putting in that await, I'm blocking execution here, something else kind of magical is also happening. I'm now telling my code, hey, we're now going to be waiting on something. So A, the runtime is going to be able to go off and potentially do something else, so that way if it needs access to the process, it can do that. But also B is I can start a long-running process, start another long-running process, maybe start a third long-running process, and then go, oh, okay, now I need that first value back. And that's exactly what's going on up above right here. So what I want you to notice right here is I'm creating two items here called 2 tasks and 3 tasks. I'm creating what are known as tasks. And in fact, you can see right here off of async IO that I'm calling exactly that. I'm calling a task. Well, what's a task? A task is really it's like a promise. It's an IOU. It's basically me setting up a method. That method is going to execute, and when it finishes, it's going to get back to me. So basically what I'm doing here is I'm saying, hey, go do this thing. And when you're done doing this thing, let me know. So promise me that you'll let me know. And it goes, yep, I promise. I'll go ahead and let you know. And then it starts going off and doing its execution. So what is it actually doing? Well, for us, it's calling this little function that we'll analyze in just a second here called load data. Now, as the name sort of implies, it's going to load data. Loading data sometimes takes a little while. So it's going to go off and it's going to load up our data. It's going to execute some long-running operation. We're going to set this up as a task. So now both of those are going to be running off to the side. They're going to be doing their own thing. And then I can keep executing code. You'll notice that right here, I've got my little doing work. Because that's exactly what's happening. Is I create those tasks. I know they're running. I trust them. They made me a promise. We're all good there. We're all buddy-buddy. And so I know those are doing those things. So I can now focus in on other things. So I don't have to stop just because I know that's going to take a little bit. Then, once I'm finally ready to go get the answer, so I've told it, hey, go load some data. Now I'm actually ready to get that data. So now I can go ahead and grab that data by using that await. So now what that's going to do is say, all right, stop here, wait until we get a response back, and then we're going to put that into, in our case, this little 2 result and this little 3 result. Now the other thing that you're going to notice here is the fact that we're doing a little bit of timing. And you're going to notice that down at the very bottom, we've already got the output there, that it's going to tell us that the operation took 3.4 seconds. Okay, well, why is that significant? Well, the reason that that's significant is load data is going to be calling an endpoint that just pauses for X number of seconds. X in our case is going to be 2 and 3. So that first one is going to be 2, that second one is 3. So if this would have occurred synchronously, this would have taken a total of 5 seconds. 2 plus 3 equals 5. In our case, it took 3.4. The reason that it took 3.4, well, you're going to notice right here that we've got our 3-second delay here, so it's taking at least 3 seconds. It's taking a little bit more than that because, again, HTTP, heavy protocol, takes a little build up a request, a little bit to tear that down. All right. Last little thing that I want to highlight on this screen, and then I want to take a look at load data, is this little mamma jamma right here. This little async thing right here. And you're going to notice that there's one right up above. So what is async doing? Well, async is saying, hey, in this construct, we're going to call await. And what that also in turn means is the fact that somebody else who's going to call this function can also await on whatever the operation is inside of here. If you're going to use await, it always has to be inside of an async construct. So you'll notice in this case here that it's inside of that little function. And if we take this one step further, if we go take a look at that load data, now what you're going to notice is that load data was flagged as async. Again, what that now means is that I can say something like result equals await load data, and then my session variable, and then whatever the delay happens to be there. So now again, my code is going to pause here. I'm saying, hey, this is going to be a long-running operation. And so now my process is free to do other things until we get the value back. But again, logically, my code is going to pause right here. It's not going to go beyond that until that returns back a value. So this little async await is going to give us that ability. It gives us a very clean way to go in and set up asynchronous programming. Now you're also going to notice in this code here that there's a couple of other libraries that we're pulling in. We're calling out to some external endpoint and so forth. And I want to tie all of that together. But I think the best way to tie all of that together is to actually go take a look at the code. So we've seen the slides. We've explained the concept. So async means that I can await on that function, and I can also put awaits inside of there. Await means, hey, we're going to logically pause code here, wait for a response to actually come back, but our process is still free to do other things if it so desires. And it gives us, again, that nice clean way to go ahead and set up asynchronous programming. Okay. Again, I think if we go in, take a look at a code, take a look at a synchronous comparison here, that will hopefully help bring it all together. So let's go do that.